Okay. Sorry, it took a while for that to get started on both platforms. All right, so here is the problem of the day. We have x parentheses kx minus 56 equals negative 16. They say that k is a constant and it's an integer. If the equation has no real solution, what is the least possible value of k? Um, So there's two ways to do this. One is to do it completely on paper, and the other is to do it with decimals. I'm going to do both ways. Okay. So for this one to do it with on paper, uh, we need to make basically an unsolvable equation, right? And so we're going to choose k or figure out what k should be so that it's unsolvable. Now, if k was just a number like 2 or something like that, we would try to solve it by isolating the x's. And we can see pretty soon that these x's we can't just simply isolate them without doing something complex. You're going to end up with an x squared, you're going to end up with an x. That's the first sign you have a quadratic equation. So basically what you need to do is you need to put everything on the left side, distribute everything, get rid of the parentheses, put everything on the left side, put 0 on the right side. We need to get it in the form ax squared plus bx plus c equals 0. So let's do that first. We're going to distribute the x. So we'll get kx squared minus 56x equals negative 16. Then we want to put everything on the left side, set it equal to 0. And then we would need to solve for x. And especially when you don't know what k is, the way you're going to solve for x is you're going to use quadratic formula. So our solution is going to look something like this. But remember, we want the solution to not work out because we want to have no solutions. So in quadratic formula, no solutions happens when this inside becomes negative, right? So we want b squared minus 4ac to be negative. And the b in this case is negative 56. And the a in this case is k, and the c in this case is 16. So we're just going to plug those in to see what k value would make this impossible or make it negative. We get negative 56 squared minus 4 times k times 16, which would be negative 64k. And 56 squared, oh my God, we won't even work that out. We'll just leave it like that for now, okay? In order to figure out what the boundary value of k is, we need to set it equal to 0 temporarily. See what value of k makes it exactly 0. And just so that we don't have to do 56 times 56 without a calculator, I'm just going to write this out as like 7 times 8 times 7 times 8 minus 64k. 64 is 8 times 8, right? So I could factor out a 64, and I would have 49 minus k equals 0. Yeah. And then I factored out the 64, and I was left with 49. And now I can solve for k. The 64 I can divide out because it doesn't contribute to making this product 0. 64 times 0 is 0. The only way that this is going to be 0 if this is 0. So that means k is equal to 49 is the solution to make it exactly 0. Now, if it was 49, then that would have exactly one solution, but we wanted to have no solution. So what we want to do is we want to make this left side less than 0. And to do that, we would need a value that is bigger than 49, because if we put in something bigger, slightly bigger than 49, then this would be negative, and it would make the whole thing negative, which is what we want. Okay, so we want k to be slightly bigger than 49. Okay, or way bigger than 49. Okay, so all the values of k that are greater than 49 are going to make this not work out. So what is the least possible value of k? If it is a integer constant, it would have to be 50, right? This is the smallest value of k, which would make this negative. and then this would be negative, and then there would be no solutions. Okay, so that is the paper way of solving this problem. And then let's do Desmos way. Again, this is like one of the only problems on this practice exam that has a Desmos out. So we see this expression here, and we want to know when this expression has no solutions. The easiest, or one way to do that on Desmos, is to set this equal to an equation, set this equal to equation, and make sure that they do not intersect. So I'll have y equals x times kx minus 56. I'll add a slider k, and then I will have y equals negative 16, and I will have these two graphs. There's the red graph right there, and the red graph, I really see any details of this graph. It is a very let's see, is it, oh, there's the other side of the parabola there. Okay, so it's a parabola. Can't really see it. And then the right side is this horizontal green line. I do not want them to intersect. So what I need to do is I need to adjust the slider so that they don't intersect. So I need to make it either bigger or smaller. So let's change this into a bigger, and I want it to be a positive. K is supposed to be a positive integer, so there's no use putting the slider so that it goes to negative values, right? And then I'm just going to like increase it until finally it doesn't intersect anymore. 48, so 49, it exactly touches, right? And so I need to make it 50 to make it not touch, and then any value above 50 is fine, but the smallest value that makes it not touch is 50. So that's how you get the solution using Desmos. A little bit, I think, easier. It doesn't take as much algebra understanding, at least. Okay, and that's kind of a standard thing. If you have something you want to solve, you put this into as y equals one equation, this is y equals the other equation, and then you just make them intersect or don't intersect, etc. Okay, so that's the problem for the today.